I'm Shoaib and I'm one of the co-founders of Geobase. I'm really excited to introduce Remote Sensing Intelligence, a project that brings remote sensing into the world of AI native applications. By that, we mean that we want to take traditional remote sensing techniques, but apply modern AI models such as multimodal models, transformer models, as well as large language models with some of the newer AI architectures that include RAGs and agents to make traditional remote sensing workflows much more accessible to the general public. By doing this, not only do we make remote sensing more easily accessible, it's also a great way to actually learn about remote sensing. So let me give you a quick tour. Here, when I come in, I can come to the landing page and I can see some of the data sets that are accessible to our starter projects. When I log in, I can either create a new project using a dataset URL from a stack registry, which is a common way that satellite image providers publish their datasets. Or I can start a project using one of the datasets that are available as sample here, or I have some of my projects that I created previously. I'm just going to go and open a previous project. And one of the first things you will see is that I can go in here and start to work with the dataset. I can add a team member to my project and collaborate with them. And here I see all the assets and their statistics that we can see for this dataset. I'm just going to go in and open the editor. So on the right here, I have my chat interface with the assistant. And on the left here, I have the satellite imagery. Let's start a new analysis. I'm just going to delete my old analysis and then start from scratch. Let's say I'm interested in vegetation. Now this data set is, we can see here, up here are all different layers that are available in this data set, or assets as they're called in the stack terminology. I can see, for example, the true color image, which will show me I can see that there's a lot of cloud cover on this image, but there's some areas which are also not covered by cloud. So let's go to the all stacks. And then I'm going to start by asking, and let's say I'm interested in doing vegetation analysis and looking at the thickness or the health of the vegetation. So I'm going to just start by saying, and when I say that, it's going to go and analyze the imagery, but also look at literature from remote sensing papers to find different scientific techniques for seeing vegetation using the type of satellite that we're using. And that metadata it's able to fetch using the data asset that we gave it access to. It's able to figure that all out by itself. And it suggested this particular index. There's a little bug here that we can fix later. But essentially, it's saying that I'm going to try a technique called EVI, Enhanced Vegetation Index, which is more sensitive to canopy structure and less influenced by atmospheric conditions than NDVI. Why did it do that? I think it realized that this image has a lot of clouds and decided that it's going to use a technique that's not going to be influenced by cloud. And here we see the formula for the EVI, and I can literally apply it, and then it can explain to me what does it actually mean by these values. So the color map we're using is Viridis, and it's got the values that are yellow, indicating healthier vegetation, and the green to blue values indicate sparse vegetation, and negative values are blue, dark blue, which are either water or soil. So here we can see that the rivers are showing up as blue. And also here we can see there's probably a lake. And there's a lot of vegetation here that's bright blue and showing up as such. So for example, we can see here patches where vegetation has been removed. And then also the surrounding vegetation here. There's a road running through here and so on. So let's ask it to, I'm interested in where the vegetation was removed. So I'm asking it to show me where the vegetation was removed. And let's see if it can figure out. So first thing it's done is gone and calculated the spectral properties of this data. And then it's applying an expression to the data, which is called it's using the NDVI index and then rescaling it to show me only the values that are from -0 to 1. So let's have a look at that. I'm having a hard time distinguishing the clouds and water from where vegetation was removed. Okay, mask out the clouds and let's try that. Wow, look at that. So I've created an expression that combines NDVI with cloud, water, And if let's say zoom in here. Okay, I'm blown away by this. It's managed to figure out a formula which I didn't know about. And it's picking up a feature here that I cannot see in. No, there's actually a massive mine here, which I really did not pick up on. And it's managed to detect that using the formula that it used to ignore the clouds, but also then build yeah, there it is. Look at that. Okay, so I'm able to get this, and for example, this mine here, I can even download this. So here I've downloaded a geotip, and I'm gonna take that and open it in QGIS, find that imagery, open that in QGIS. Here it is. And we can see that this data is in the right location by zooming out and seeing that, hey, it is indeed in the Amazon. And there it is. And I'm going to zoom back into it. We can see here that in our OpenStreetMap, this mine has actually expanded. And in OpenStreetMap, we haven't actually mapped this data yet. This would be something that, if possible, we could even ask the AI to update. So yeah, that's that. And now let me quickly go back to some of the other things on the roadmap. So we're adding more models soon. Right now, it's just talking to an LLM with the contexts and some of the smart agents that we have and the tooling that we've added. And the next thing is to create the ability to take this image and also add multimodality. And we're almost there. We have already got the candidate models and are potentially looking to train our own. So it's a really exciting time. We're really seeing an opportunity to reinvent it and reimagine it in a way that was not possible previously. Let's now analyze water. I want to see maybe how fast the water might be flowing. Now, I don't think there's a way to actually do that from remote sensing, but the AI will have access to understanding of certain indices, and it may be able to infer from that an index that can give you a proxy parameter for the speed of the flow. So it says it can help us identify water turbidity and movement patterns, which can indicate flowing characteristics. So let's just say apply that. And wow, look at that. So we've got now, let me also try a different index that might show sediment pattern. And red plus green divided by NIR ratio for water pixel only. So the green and yellow are high sediment, and the blue is clearer water. And that certainly that might be the case because the closer you are to the edge of the catchment or the streamlet, the higher the speed of the water coming in. And so the water is more turbid and has more sediment. And the further out you go, it slows down. And we're certainly seeing that here. And yeah, that certainly checks out. So look here, what's going on here? Oh yeah, this is very interesting here. This pattern, as we're closer to the edge of the riverbank, the water tends to have higher turbidity as it interacts with the edge of the riverbank. And further away from it is less turbid. So we have extreme reds here as a result of that. This, I believe, might be some interference from the clouds, which is something we can't really do much about. Very cool. Later on, we'll be able to add more models here, which can do multimodality and have a deeper understanding of remote sensing data itself. But this is just a highlight of what is now possible already. Let's ask it to see buildings. Okay, so it's telling me that, so this area was all black before, and now we can start to see here there's some kind of roads and road type patterns here. Here's even more contrast. Look at that. Wow. So this is really isolated. All the areas, there are buildings. You can see there's probably a road here. It's running through this area. And it's been isolated using a technique called Enhanced Built Up Index EBBI. And again, this is all coming from the literature. I can ask it to cite the source. And here it is. Look at that. It's a real paper. And yeah, I'm impressed. I'm from remote sensing background, and I'm really impressed by what we're able to accomplish now. And I think this is completely going to change the way we do things in the remote sensing industry. And yeah, looking forward to any feedback and talking and having a conversation around how we see this evolving.